Let me move now to introduce Doug. Douglas O'Regan is a historian of science, technology and business based in Cambridge, Massachusetts. Gained a PhD from the University of California in Berkeley, has held teaching and research positions both there and also at MIT and Washington State University. Now, he joined us at the Institute as a Seidel Fellow in 2014 to 15 when he was finishing up his dissertation. And while with us, he was mostly using our oral histories of scientists and industrial workers to tease out how their tacit know-how gave them at least some bargaining power, despite unfavorable legal trends during the 20th century in patent law, for example, which gave corporations more control over technology and workers, something that is very topical today. Now, this work was closely related to his much larger research project into American, British, French, and Soviet programs to appropriate German science and technology after World War II, and the legacy of these programs through the present day. Now, last year, Doug published his findings in a book called Taking Nazi Technology, Allied Exploitation of German Science After the Second World War. And it's this international race for German science and technology that Doug will be talking about today. And I understand he might draw some historical lessons in the present related to US fears of Chinese industrial espionage. So let me hand over to Doug. Doug, welcome. Thanks so much for joining us today.
Yeah, thanks for having me. And thanks to everybody for being here. I know everyone is usually out partying in bars and clubs these days, so I appreciate you taking the time to be here now. It's a little odd thing that we're all getting used to, I suppose, sort of giving what's called a lecture in this sort of format. And I find questions are usually a little more to the point of people's interest. So I'll try not to go the full time, but there are a lot of side stories here that I want to at least hint at, touch on, see what people are interested in. Because a lot of times when you hear something about this story, the what's been called the race to loot Nazi science, the efforts to seize German scientists, technologists, what you see most commonly, people who've heard about it, is Operation Paperclip and Werner von Braun and the moon race and the German scientists showing up in Argentina, or pop culture versions have them all over the place. And there is some truth to that. That is a part of the story, but it's only a small part of the story. So what I want to do today is talk about sort of this larger context, maybe draw some parallels to the British, French, and Soviet cases, because those countries also tried to take German science and technology, sometimes cooperating with the US, sometimes competing with the US, and then talk a little bit about how that had consequences for the longer term. These are interesting in their own right, but they also have some legacies that live on today. So that's basically the structure I described. And the first question to talk about is, why was everyone so interested in German science and technology in the first place? But after the war, you have forces racing along the front lines in dangerous territory, still contested territory, seizing German factories, archives, research facilities, holding them against enemy lines, getting into ahead of the actual army in a lot of cases. Why was this so important to people across the spectrum? Some of you might be familiar with this, but I found a lot of people aren't, which is that Germany really had a really strong reputation before the war as being elite when it comes to science and technology. Some of that comes just from academic science, and a lot of people who you might have heard about were impacted by the rise of the Nazi state, fled persecution, especially the Jewish scientists, though not exclusively them, and ended up in the West. So there's a lot of big names, not all of them fled, but Max Planck, Johannes Stark, Gustav Hertz, Werner Heisenberg, Albert Einstein, so many really prominent German scientists whose names still ring out today, either were active in Germany and lots of them fled to the West, which then advertised to the rest of the world the excellence of German science. Even at a popular level, people were aware of this celebrity of Albert Einstein. And this gave even more of an impression that had already been around of German scientific excellence. By 1944, more than 133,000 German Jewish immigrants had arrived in the US. Hans Bethe, John von Neumann, James Franck, Edward Teller, Albert Einstein, among the immigrants who ended up in the US. And it wasn't just academic science. An awful lot of industrial technicians, workers, skilled, what today we'd call skilled immigrants, came over fleeing Nazi persecution, and what not only brought their skills and their knowledge and their know-how with them, they also, through doing that, sort of advertised the excellence that had been prominent in Germany before the war. There's an economic historian, Petra Moser, who has studied which in fields of chemistry, specific subfields of chemistry, where there were more of these German Jewish immigrants who came to the US after World War I and between World War I and World War II. In those specific subfields, there's been more inventing more patents filed than there were in fields that had fewer German Jewish immigrants, controlling for the overall sort of growth in the sort of related fields. So there's sort of a proven benefit that America got, as well as other countries, from these German Jewish immigrants. And that led to a lot of higher estimation, I think, as well. And there were long-standing ties between scientific communities of these Western countries that were to some degree disrupted by World War I, but were built back up to some degree during the Weimar era in between the wars. And American, British, other scientific institutions very commonly would send their brightest students to get their PhD in German institutions, at least in some fields. And this really led to a lot of people thinking of Germany as the best in the world. And they were in a lot of ways. There were a lot of fields where Germany really was at the front, primarily in chemicals. The cooperation between the German chemical industry and academic research institutes was a model that has been mimicked by a lot of places around the world since then. During the war itself, there were a number of other German inventions that really made people think, in addition to Hitler's propaganda that they had all these great secret super weapons, there actually were some sort of super weapons in a sense. There were advances in tanks and, near the end of the war, jet engine fighters. There was most prominently the V-2 missile, which was the first sort of self-propelled navigated missile, something like today's cruise missiles in its most basic form. And this was a terrifying weapon. It turned out not to be terrifyingly effective in the sense of killing people that they wanted to kill, but it did really scare a lot of people for good reason. You couldn't necessarily hear it coming. It went faster than the speed of sound. And so suddenly there would be explosions in London and people dead around you. And this sort of fear, not even being able to hear it coming, really caused a lot of terror, not only of that weapon, but of German ability to develop more weapons of that kind. And for those in the know in the US and abroad, US, UK, at least, I mean, we were developing our own super weapon. The Manhattan Project was developing atomic bombs based on information to a large degree started, at least, in Germany. A lot of these German Jewish immigrants contributed to the Manhattan Project. And so, again, people feared throughout the war, at least those who knew about the Manhattan Project, where were the Germans on this? That was a driving fear and driving question that they would win the race to the atomic bomb, if indeed an atomic bomb was possible, which we didn't really know until we knew. So anyway, the point is that Germany had a really, really strong reputation internationally heading into World War II for being the best in the world when it came to science, technology, military science and technology in particular. It turns out this is not necessarily, as I'll talk about throughout the lecture, a full reality, but that was the impression that a lot of people had at the time. And so that led people in the US, UK, France, Soviet Union, and a lot of other countries who were allies and had less of a direct leadership role, but also were involved in the war, to want to take German science and technology. They wanted to learn everything they could and turn it to their benefit in the war on Japan, which was still to take place. They also wanted to gain everything they could at an industrial level and in a number of different agencies within the US and a number of different agencies and private institutes and enterprising individuals within the UK and also France. This idea occurred to people that you could take not just the military science and technology, but maybe we wanted to learn about all of their industrial science and technology, take their patents to whatever degree is possible, take what some people then call intellectual reparations from Germany. People had learned from World War I that taking monetary reparations could cause as many problems as it solved. The cycle of reparations and payments and loans was one of the many causes of destabilizing Germany, Weimar Republic, and leading to World War II. And people were not very keen on that, even if they thought they could get reparations out of Germany. At least in the US, we weren't very keen on it. there were more people calling for that elsewhere. But people still thought we could get intellectual reparations here. We could still get patents. We could still get technologies and benefit at the expense of Germany without necessarily completely destroying Germany. So what that looked like in practice, in addition to looking at rocketry and these particular facilities, was within each of the occupation zones of Germany. Germany, once occupied, split up into areas controlled by each of the four major powers. Well, three major powers, and then the US and UK split their zone to give France a zone because they wanted France to have a little bit more say in things despite Russia's objections, Soviet Union's objections. But within those zones, each of these countries started building missions to acquire German science and technology. And it wasn't just, again, it wasn't just one entity who was trying to do this in each country. There were a whole slew of agencies who sprang up. Just within the US, this is just a sort of brief organizational chart. I'm not going to go through it in close detail, but a wide variety of agencies, even during the war, were sort of competing internally within the US to try to get this done. There was coordination with the British, of course, because we were operating under a shared military apparatus during the war. And then after the war split, it becomes even more complicated. And again, you don't need to sort of study this closely. The point is, to some degree, how complicated this is, because there are so many different types of missions who were involved in trying to take German science and technology. There was what's called ALSOS, which was the mission to study how far along did Germany get in their equivalent to the Manhattan Project. There was the Strategic Bombing Survey, which wanted to know how effective was the mass bombing in taking down German industry. But along the way, they also wanted to know how much was German industry still capable and how much had German industry been able to do beforehand. And so it very quickly sprawled into a mission to find out everything they could about what today we call economic intelligence, everything about the German economy. There's the Technical Oil Mission, in which a number of oil companies came to the US government and said, we want to know more about German oil-based technologies, synthetic rubber, synthetic gasoline especially. And so they were able to put together a mission and send them into Germany. Army Ordnance Mission, Navy Technical Mission, and those are all what I sort of consider side missions. There was also Operation Paperclip, which is a more famous one I'll talk about in just a moment. But the biggest deal, I argue, is the one sort of over here. I don't know if you can see my mouse on the screen, probably not. FIAT, or TIC, Field Information Agency Technical, was the US side of this. And within Germany, it was called Technical Intelligence. Oh boy, I'm forgetting the name. Anyway, it's another of these acronyms. And these two agencies were basically the same agency, one in the US, one in Germany. They coordinated based on lists where the Commerce Department would go to US industry, would ask either industrial leaders or put out articles in trade magazines, Chemical and Engineering News, or these other trade publications, and say, if you have some idea of what's valuable in Germany, come talk to us. We need to find out about. Are there people we need to speak to? Are there libraries we need to look into? Are there industrial research facilities we should look into? Are there particular technologies we need to know about that even if you don't know exactly where we're going to find them? They then compiled these lists, sorted them according to how secretive they wanted to be, black lists of the most important and most secretive, gray lists of those that were maybe a little bit less crucial, and then white lists that they were able to freely share with their allies, with the Soviets and the French. And so then they would send these lists to the Commerce Department. The Commerce Department would recruit investigators from industry. So again, through these publications, they would find companies and say, do you have some engineers you would like to send over to Germany for a while? They'd get paid nominally, especially early on. You got some of the bigger companies sending over their engineers for essentially free. The Fiat would then send these people to Germany. They would be given cars, they'd be given microfilm equipment, camera equipment, they'd be given research teams, either organized by industry or by the particular facility they were going to investigate. And then those teams would drive to wherever they were going to go in Army uniforms as if they were colonels in the US Army. They had that level of authority. They could call on the US military occupation force to enforce their ability to go into these factories or other facilities. And they would set up camp and they would be able to interrogate people. whether technicians or engineers or scientists. They would spend their time photographing every document they wanted to. They would then send these microfilms back to the Commerce Department, who, in theory at least, would write up all of their findings as a report and sell those reports to the US public and to the public at large. And in theory, therefore, everyone would gain perfect access to all of Germany's inventions, all of Germany's science and technology. So that was the game plan. And the goals here were not only to acquire this information for the US, but to some degree to deny it to other countries, including very quickly in the Soviet Union. That mission changed to some degree over time. And in theory, these reports were available to anyone who wanted to buy them. And in fact, the Soviet embassy ended up buying a copy of pretty much every one of these reports at a very high cost in a time when the Soviet Union was really desperate for foreign currency. So they paid a cost for these. But in principle, they also didn't end up writing or publishing some of the reports for more secretive issues. So I will mention Operation Paperclip is the more famous of these. It was focused on bringing over German scientists who they deemed to be particularly important. The most famous and the largest component of these were the scientists involved in the V2 missile. And Werner von Braun led one of the larger teams they brought over. He's a fairly famous figure who became important in developing the Saturn V rocket that was involved in the moon landing. He became a very popular figure working with Walt Disney on educational documentaries in the Cold War era, and generally became someone that almost a household name, at least fairly well known as this emblem of the German scientists, some would say Nazi scientists. And some of the people brought over through Paperclip were in fact diehard Nazis who otherwise would not have been able to come over to the US, at least in theory, because of the denazification requirements and public sentiment, obviously. But through Paperclip, they were brought to the US. Not only as rocket scientists, also some people involved in medical research and other fields. And that is the more famous topic here, but a little bit more narrower in execution. So a pretty good size number of people brought over as part of Paperclip. This is a picture of prisoners in Ashcan, which is one of the two internment camps specifically for scientists and engineering personnel, or others who, like Albert Speer, who essentially led the Nazi economy for some time and could sort of point to where the bodies might be buried in terms of where could we find the scientific materials we might be interested in. The US and UK together operated Ashcan and Dustbin, a similar camp, during the war and soon after, and nearing the end of the war. So that was the game plan, but it didn't necessarily work out quite as well as we hoped. I guess first I should say, what did we get? What did work out in terms of what we got from German science and technology? There were some successes. The V1 and V2 rockets, we were able to get a large number of people who had expertise in those, and we were able to get prototypes. We were able to get a lot of research files. Actually, the development facilities for the V2, at least the primary development facilities, were in what became the Soviet zone of occupation. But the US Army got there first during the invasion, packed up everything they could, and shipped it to the West just before the Soviets officially took over, which, as you could guess, the Soviets were not very happy about. The US also learned some about German tank designs, jet engine design, though also the British had their own program for jet engine design that was available as well. Some audio recording technology useful in radio technology. We learned a lot about synthetic gasoline and synthetic rubber, which during the war was immensely valuable because during the war, Japan cut off a lot of American access to rubber plantations in Southeast Asia, and gasoline was a priority as well for obvious reasons. With less circulation, less access in some ways, especially if Germany had invaded Egypt and shut off the Suez Canal, gasoline would have been a lot harder to come by. And so people saw this chemical technology as being particularly important for national security. So people learned about that soon after the war, with Japan no longer and no more threat of Germany shutting off the gasoline or rubber sources. The synthetic rubber and synthetic gas mission actually ended up just packing up all their files in the archives it was too expensive to put into effect, and it sort of just went on the back burner for a long time. But then in the 70s, when there was an oil crisis, people got interested again and started looking into these files, actually translating them for the first time and trying to see, oh yeah, how did Germany do synthetic rubber and synthetic gasoline so efficiently during World War II? So some of this comes back a little bit later than you might expect. America also got some sort of more physical reparations along these lines, particularly wind tunnels. Germany had some of the world's best wind tunnels and largest wind tunnels, most powerful wind tunnels. The US had very few during the war, and some of the German wind tunnels were important in American aeronautic history after the war. And we brought a lot of people over, not as many as the UK, I think, and maybe we didn't get full use out of them to some degree. A lot of the German scientists who were brought over for the sake of not allowing them to go to the Soviet Union, rather than because there was a great need for them in the US. And some of them ended up on army bases without any US industry companies particularly interested in hiring them, unless they were sort of nudged to do so by the government as an act of patriotism in a way. But we did bring over a lot of people and probably a lot of great ideas and skill sets along the way. So that's what went well. But as I argue in the book, that's not the really big story to me about the American exploitation of German science and technology. There were successes, but the bigger story was people going over to Germany, trying to take what they could, and finding this problem that you just can't capture in reports or in sort of photographed documents. No matter how well you write the report, no matter how much data you print out, no matter how many photocopies you make, you can't capture technology that way necessarily. What you really need in most cases is what people at the time started calling the know-how. You need the skill and experience that you develop when you're on the factory floor working with these technologies, or you're in the lab working with this particular way of doing a calculation, or you're otherwise doing the hands-on training that you've worked with somebody who's a master of the skill and they pass it on to you and you learn in person that way. That sort of know-how component is something that these programs were not set up to capture, other than this more limited engagement with bringing people over. Instead, they were focused on these reports. And so you start seeing items in the document, you start seeing documents all over the place complaining no effort has been made to obtain the so-called know-how, which can only be obtained on the ground by qualified engineers and technologists. Mechanics can often visualize how something can be made if they look at a thing over, easier than they can if they have to look at it from photographs. The only method of transferring know-how was to permit visits to the actual works of the firms. And so you started getting people pressuring the US government to revise these programs. Instead of a quick visit and make photocopies and make a report and distribute the report, send over engineers to spend more time in the labs, actually in the industry in which that engineer works. And the more time they can spend there, the more they can actually develop this know-how. The problem was that was expensive, and these programs did not last quite as long as they might have, and so that didn't end up working quite as well as people hoped it might. It's worth taking a quick sidestep to talk about, well, I won't go into too much detail here. I will say this was a tight connection between the academic science world and these investigators. Pictured here on the right, Roger Adams, who is a professor at the University of Illinois. He led a number of other people who went on to very successful scientific careers, including Gunther Stent and Nelson Leonard, pictured here, to be investigators in Germany. Adams himself went over to be the scientific advisor to the occupation government in Germany. And Adams was tightly connected with the sort of early intelligence apparatus who was involved in exploiting the German science and technology. And this is just one of the sort of ways that there were these tight personal connections, these tight recruitment veins through academia that tied right into the intelligence programs that ties straight on into today. I won't go into a lot of detail about them for the sake of time, but they do sort of illustrate some of what was there. Stent really sort of applauded a lot of his time there. He said he found a lot of great stuff. Leonard, on the other hand, found that when he was sort of dumped into Germany, he was paired up with a team of investigators. They went to these factories, and in talking about these huge microfilm archives they were making, He says, how am I supposed to do this? Go from one place to another and simply say to the crowd, as he said, in charge, tell me about the secret technical information you have, mister? What if he lies? Like, frightfully sorry, sir, I haven't got any secret technical information. Am I supposed to extract the truth by torture? They were not supposed to extract the truth by torture. In fact, there are some records of people being jailed and interrogated in the sense of asked a lot of questions in not necessarily perfect circumstances, but this wasn't a sort of torture situation. And so it points out the difficulty of getting anything that you couldn't convince the Germans to tell you other than what was written down. And again, what's written down isn't all that you need necessarily. And people kept finding this problem of we're capturing an enormous amount of information. Much like today, people thought technology was going to solve all of their problems. The great information technology at the time was microfilm. Anyone who's used microfilm knows that it's not such a pleasant technology to work with, but at the time it was revolutionary. You could pack an entire library almost into a cabinet because you could take photographs of everything, make it into microfilm. In practice, what that meant was an early form of data hoarding, in a sense. People just taking photographs of everything, copying it onto microfilm, sending it to the US, and then not really having the immense amount of time and cost it would take to translate those, make them into valuable reports, and distribute them. And so you have these massive archives of microfilm that even today, I think, are in archives, but some of them have never been opened up since they got back to the US. This information flow problem, that technology not only can't necessarily be captured in written form, but can't be translated that way so easily. You can't just take a huge amount of information, dump it on somebody, and then, oh, they know the whole thing. There's a reason that these massive online courses don't necessarily mean that everybody is a brilliant, super educated genius in every field. The access to the internet doesn't make everyone know all of the actual information that they might want to know even, because it's actually a lot involved in learning and adapting and using, instead, not just capturing in photographic form. That, by the way, since other sort of foreshadow ahead of time, that I think is my criticism today of all the paranoia and panic about Chinese industrial espionage. You hear so many terabytes of information have been copied and shipped away. Cyber hackers have broken in and copied all of this information. I'm sure there's some value to that. There was some value to the records taken through Fiat and TIC and these other programs. But by and large, if you want to recreate a technology, over and over again, what American companies found from their investigation of Germany was that even in the cases where they wanted to learn something from German technology, it was extremely hard to do so just from the written form. You really needed more time and more in-person investigation if you wanted to learn how to use it effectively. And so I think that is, it's not completely a red herring to worry about cyber espionage, but I think it's a little bit overblown because it's easy to put numbers on the number of gigabytes or terabytes. It's a lot harder to talk about in-person investigations. Okay, so moving forward, I'm not going to go into a lot of detail about liaison with the UK, but I will say that you can't really tell this story as just a US story. The US and the UK had combined operations throughout the war. In a sense, they had mirrored versions of this. The US had Fiat, Field Information Agency Technical. The British had BIOS, the British Intelligence Objective Subcommittee, did pretty much the same role. The Americans had Operation Paperclip, or Operation Surgeon was a related effort. The British had the Darwin panel, where they were also aimed at bringing over scientists who they particularly wanted. France had the Comité de Coordination Scientifique, apologies for the pronunciation, which was also analogous to these. They weren't quite as closely related, but the Americans and the British really worked together, not only in their planning and not only in their execution, but also in sort of pushing each other to go forward. In both the American and the British archives, if you go read their archives, you'll come away with the impression that the other side was racing ahead and already doing this, and we need to catch up because we're going to miss out on this great loot they're getting. They're learning so much from Germany already, and we're so far behind. Maybe we can put together a program and coordinate with them. But both of them can't have come first. Both of them can't have raced ahead. And I think in practice, both the Americans and the British had people who understood that that was an effective tactic for getting the higher ups to approve these programs. I think the British were a little bit ahead of the Americans in a lot of ways, but in general, they both kept moving forward on these programs, and both ran into a lot of the same sort of problems, incidentally. the British also ran into this know-how problem. They solved it by sending a massive amount, well, relatively a massive amount of people over to Germany to actually do these in-person investigations and spend less time writing reports. That then frustrated the Americans who thought the British were withholding reports, but they weren't necessarily. They weren't spending as much time on reports because they didn't see them as quite as useful. Okay, another issue I'm not going to go into detail about today, but is worth raising is that when it came to German science technology, there was an attempt to, you could say, loot, to get intellectual reparations. At the same time, there was a question of what do you do with German science? You want to learn from it, sure, but how do you picture science in society? Is science this democratizing force? Is science good for a democracy because it's open and there's civil and civic civil disagreements? People disagree in theory, amicably. In theory, they share all of their findings and how they got there, and merit is what determines who wins the argument. Right? I think we know in practice that's not always true, but that's the theory. Or is science the way to military technology, and we need to crush German science in order to prevent them from having military power again? These were active arguments about how to deal with Germany that each of the countries also thought about in their own country. So the US is both talking about how do we keep Germany from becoming a military power again? Is it by helping science or keeping science down? And also, how do we, America, become stronger? Is it by promoting science for this sort of democratic, open science? Do we need to instead invest more heavily in military technology? That's not necessarily an either-or proposition, but the debates about what to do in Germany, in addition to the intellectual reparation side, had to do with how do we deal with science ourselves and how do we help others when it comes to science. I'll sort of skip over France here. I will say that France was sort of on the outside of things. They wanted to be involved in the American and British side. The Americans were not as involved, were not as interested because they were very suspicious of the French. They felt that the French were far too likely to fall under Soviet influence because there were active communist people, active Communist Party people, including in the scientific establishment, who had fought against Nazi occupation and now held power in the restored France. And in the early Cold War, as that developed, people were very suspicious of that. At the same time, the Soviets were also very suspicious. The French were sort of pushed to the outskirts, but the French did try to be involved and felt that really they needed to focus on the people as well. And so they built institutes, cooperative institutes, where both German and French scientists would work together and train French scientists, students, to learn about German science and learn the quality that were involved in German successes in the labs without necessarily just trying to rip people up and move them into new places. I'll also skip over the USSR. I will say they were a little more brutal than anyone else. They're well after all of these programs I've been talking about for the most part. The Soviet Union decided that they weren't going to be able to control Germany forever, as might have been the original plan. They also thought maybe Germany was going to have a uprising in favor of communism, and so maybe Germany would just be their ally. When that became less and less likely, the Soviets decided they were actually going to do something like these programs, but more brutal. And so overnight, they essentially kidnapped massive amounts of German scientists and technicians in Eastern Germany and swept them into the Soviet Union, where they would stay for quite a number of years to come. When they came back to East Germany, they were actually both productive and important in East German science. But there was this sort of mirror. And when that happened, it got headlines around the world. And the Soviet Union was then able to say, well, what do you care about what timing I took my scientists? We're doing the same thing you just did. The Americans denied it, but in reality, there was some truth to that. Okay, so what lessons do we take away from all of this? Well, one of them that people took away at the time was that America should be a little bit less thinking of themselves as the second-hand scientists, that stop thinking of themselves as in Germany's shadow and start thinking about themselves as world leaders in science and technology and industrial science and technology. What that means in practice is both that you're less deferential to the Germans, but also that you have this, with this leadership role, your science and technology can become something you offer to others. So in this early Cold War era and throughout the Cold War, you start seeing America using science for diplomacy more actively, trying to, what they would say at the time, build up these third world countries through scientific missionaries who would go and spread American know-how by being embedded in these countries and help them learn industrial science and technology. And since American industrial science technology was the best around, they felt they could do this in an effective way that would draw people into America's camp. And these places would be so excited to learn from American science technology, and not necessarily as much from German or Soviet science technology. Just as far as one quote I found kind of funny, the Eleanor Roosevelt show. Eleanor Roosevelt had a somewhat popular radio show in the 50s. And at one point, she was interviewing John Green, who was head of the Commerce Department unit, who was responsible for publishing all of these fiat reports in the US. Green says, "We had a pardonable feeling that we have a monopoly on brains, but of course it isn't so, and there are some marvelous individual thinkers in Europe who are hard at work today. And we can always hope that we'll be able to borrow the knowledge of Europe, and sometimes think of that as a sort of reciprocal Marshall Plan to be able to take ideas of Europe." To which Roosevelt replied, "Yes, in the old days we did once upon a time think of Germany, when they were allowed to think before the Hitler days, of them as very good scientific research people and inventors." So that just sort of shows the level of popular change in attitude, even by 1951, that once upon a time we thought of Germany as good in science and technology, but by the 50s, that's sort of a laughable thing in a lot of viewpoints. Okay, there are a couple other big lessons I'll at least hint at, and we can, if people are interested, we can have questions about them. If not, I go into more detail in the book. One of them is this curious case of everyone being interested all of a sudden in know-how. The term basically didn't exist in the English language until this era. The concept to some degree did, but the term itself rose and it became embedded in the law of science and technology in this period. I found that a very interesting thing connected to these efforts, even if they're not necessarily caused by them. I think they're pretty closely tied together. And then the cyber espionage story. People at the time in Germany were very concerned about this. In practice, the German economy flourished, the West German economy at least, in the years right after these programs. However much we might have taken from them, they actually gained quite a lot from American companies knowing exactly what German companies could do, and German companies knowing what American companies needed from them. And so after the war, you start seeing closer ties in terms of licensing agreements and production agreements, foreign direct investment, partnerships, in part because of this information flow. Even if it didn't allow the Americans to steal the German inventions, in all cases, it did allow them to know what was there. And so there was actually, to some degree, possibly a net benefit to Germany from these investigative efforts. And that brings back to the question of what exactly do we fear about other countries learning about our technology? There's a real fear there, but I think to some degree it's blown up for the sake of getting funding for intelligence agencies and consulting firms who will help you guard against this terrible, scary threat. Okay, I'll stop there and let's see if there's any questions anyone has. I'd be happy to answer them. Thank you.
Thanks so much, Doug. That's a really fascinating story. I mean, like, even as a historian, you expect there to be kind of local, national differences in the approach to technology appropriation, scientific practice and methodology, and so on. But yeah, I think certainly the Soviet example kind of brought home to me just how varied these approaches were between the various different countries. Let me just delve right into the meat of your talk there. I was very fascinated to learn about the phrase know-how and how this a brand new term in about from the 1940s or so onwards. Obviously, you're aware that historians of science and technology have produced, like, especially in recent years, a large literature on this, what they would call tacit knowledge. Particularly on this idea that you have to move materials and people between sites in order to do things like replicate scientific experiments, technology transfer. I mean, I remember when I was postdoc, at Cambridge, learning about similarities between Boyle's use of the air pump in the 1960s and the development of the laser in the 1980s and so on. So I wondered, with your specific case in mind, if we could tease out anything more specific about the conditions under which that holds true. I worry a little bit that we take it sort of now we take it, like, at least within the academic field, somewhat for granted, right? That it's just universally true. rather than thinking carefully through the specific conditions under which person-to-person contact is required. And just to sort of, like relate this to our new digital reality, I was doing some origami, like through Zoom with my son, who obviously is not in childcare at the moment. And trying to watch someone on a screen, fold the individual pieces of paper, and I sort of thought to myself, thinking, there's no way I could do this by instructions. This is very hard by this sort of digital screen. And yet, if I was with them, I'm sure it would be a lot easier. So, it's just that kind of thing that I'm getting at. And can you relate that to your particular story of technological appropriation?
Yeah. So there are sort of two sides to this. One is the know-how thing itself, and the other is sort of how aware we are of it. I mean, obviously, tacit knowledge, know-how, whatever you want to call it, has always been around. It was the basis of the early modern guild system. You have the master craftsman who would bring on an apprentice, and that apprentice would work with them for years and then go off and be a journeyman with another master, and then would start up his own shop somewhere. And the very beginning of the patent system was to bring over people who had these skilled guild-based knowledge to a new country and give them a monopoly for a while in order to get these technologies to flow. The idea has always been around. It's always been important. But I think people became aware of that importance to a really increased degree in this era, and to some degree because of this episode, in part because they now had the technology to capture as much written format as they want. You can't imagine that the problem is we don't have enough documents when you have the equivalent of a library's worth of documents about this particular chemical technology, and you still can't make it work. So then you have to ask, what else is missing? I think today we do have more ability through video, Zoom, YouTube does a great job of transferring more of this sort of know-how than you would get otherwise. But especially at the time, this was something people were paying attention to, I think, because they now had the information technology to allow them to do all the writing they want, and they still couldn't get it necessarily. I'll also note that today we sort of take it for granted in academic circles, in part because of the work of Polanyi and some of these other philosophers, but they were writing in the 50s and later than that, in part drawing. This was happening in the mid 40s to early 50s. Gilbert Ryle starts talking about the concept of tacit knowledge and know-how in, I think, 56 or 57 in London. Polanyi at the time is in London working in science and technology, and then writes about tacit knowledge later, I think in the 70s. So this all, I was never able to do the research project to see, is there a causal connection there? But the attention in the academic world certainly comes right after this becomes such a big deal in actual industry and science. And also say this isn't just like an academic thing. Know-how went from being something that didn't exist in industrial agreements. If I was trying to share my technology with you, I'd have a patent sharing agreement maybe. That was a big deal already in the 20s, 30s. But those agreements wouldn't have typically any sort of provision about know-how. In the late 40s, 50s, 60s, there's a sharp increase in these agreements, more commonly at being a patent and know-how agreement. And sometimes just know-how agreements became even more popular than patent agreements, where you would send your people over to their factory for a period of time and be responsible for them being able to actually produce the thing, not just have the right to produce it or schematics, but I have to actually teach you how to do the thing. It became a big deal in the hard-nosed business of industrial production before it became a thing that philosophers and historians talked about a lot.
Yeah, and that's really fascinating. I mean, just as a really quick follow-up to that, did you find any pressure on the access category of intellectual reparations? Did you find that they stopped talking about it in that way when those who are running these projects began to realize that the know-how was more important?
I don't think that term particularly ever really changed. I think people definitely talked about it as reparations at the time when they were promoting it. In the U.S. case, the program started getting some pushback pretty early on, relatively. So by the late 40s, certainly, from the people in Germany who wanted to build up a democratic, strong, what would become West Germany, to stand as basically a buffer zone between the other Western European nations and the Soviet Union. So if you want a strong democratic West Germany who can stand up, then you probably don't want to strip away, as they saw, all the science and technology. So there was always a tension there, and eventually that side got a little more power. So the talk about reparations started getting pushed under a little bit faster in the US than in the other cases. So people talked less about reparations at that point. In the US case, we didn't really adapt our techniques as much in response to the complaints about know-how. We just sort of sped things up and finished the project, and it was just sort of on the sideline. It was really the UK who changed their techniques more in response to this problem, and the French who took a very different approach altogether because of the problem. The US sort of went ahead with the report writing and then found that a lot of it wasn't actually quite as much use in retrospect in the report format, other than what people learned who were actually on the ground there investigating industries that they themselves knew.
Right, and the French, of course, as you alluded to in your talk, had the geographical advantage,
right,
proximity to Germany.
The UK did too, in the sense that it was much cheaper to send a lot of people to the UK from the UK to Germany than from the US to Germany.
Yeah, that's definitely true. So let me ask a couple of audience questions now. Was there any similar program or effort to exploit Japanese science and technology after World War II? Even though it didn't command as much high esteem as German science and technology?
Yeah, there was. So from the research I did, which did not focus on this, and from the articles I read going into it, these programs did exist. They were a lot more limited, and the American industrial the American companies were a lot less interested in general in investigating sort of this. When it came to Germany, they were interested in everything, not just tanks, but watchmaking, toy making, wood pulping, chemicals, dye making, all those sort of types of chemical type things, machinery, machine tools, optics, everything you could imagine. American industry was interested in what Germany had to say. There was some interest in some things Japan did, but there was both a sort of racial component of imagining that the Japanese were good imitators, but they weren't necessarily what they called the Germans ingenious Huns or ingenious barbarians, whereas the Japanese, they sort of imagined, couldn't necessarily invent anything particularly amazing themselves. I have read since then some discussion that maybe there were more extensive efforts in Japan than I've known about, and I could only sort of trust that researcher to have done more research than I have in that area. I haven't read the article that was in progress the time I last talked to the person about it to sort of give more detail. So short answer is, yes, they happened. They were much more limited. And at that time, American industry was also probably less interested as a reaction to having tried it so much in the German case with less success. This will be a good bit later.
Are there any studies that you know of into this? I was being asked if you could name a few works possibly to look at.
Into the Japanese case or into the overall case?
Yeah.
I can't remember offhand for the Japanese case. The work was still in progress when last I talked about it a couple of years ago, and so I didn't see what sort of the title of the article or book would be to reference it. If someone emails me or passes on an email through Science History Institute, I'd be happy to do some quick Googling and send along some links.
Great, thanks, Doug. Yeah, we always heard about the evil Nazi experiments on humans. What, if any, important results did we learn about? Any life-saving, enhancing science developed by these unethical experiments on humans?
Yeah, I think the main ones had to do with how people can survive in extreme strength. So the Germans wanted to know if your pilots had to eject from an airplane really high up in the sky where there's very little oxygen, how well could they survive? And if they plunged into icy cold waters, how long could they survive before being rescued? And so they took some concentration camp victims and stuck them in hypothermic tanks to see how long would they survive. And they put them in low oxygen environments to see how little oxygen could you survive on. I think some of those studies produced information that you would occasionally see cited in American literature decades later, controversially. Obviously they weren't necessarily the gold standard of scientific research. At the same time, people didn't necessarily want to try to replicate the results. Some of these also, I think, were more torture than they were science, and then later on got sort of wrapped up as, oh, this was just good scientific research. I was trying to help save people's lives. So there's some degree of that too. But I think there's some element that people did research on those particular areas that I think people saw some value in, whether or not it was the best science, or obviously it was horribly unethical.
I have a question now on whether or not there were any parallels to the gold rush when the Soviet Union collapsed and US companies and so on began to have access to Soviet science and technology.
That's a good question. I haven't really looked into that case in enough detail on the Soviet case to sort of make the parallels. I think the main difference would be that in Germany, at least, we were an occupying force, and so we had the military might to sort of make people talk to us, as opposed to after the collapse of the Soviet Union. Certainly, the U.S. had a lot of leverage, and U.S. companies had a lot of leverage with regard to Soviet companies, but maybe not quite the same type of leverage, and also it not being orchestrated by the U.S. government for the sake of the entire U.S. industry and sort of Western industry. Also probably meant that companies were more interested in helping themselves in a targeted fashion, which may have meant they were more effective. It also meant probably not as much broader access to whatever the results would have been.
Now, I remember meeting somebody once who was actually involved in that process, and the one thing I remember distinctly from that talk is he spoke about the cultural differences of moving from communist to capitalist systems of production, and he said that the one thing that he couldn't possibly get one of the leading foremen in this factory that he was visiting to give up was the particular branding of this product. We have a question about whether or not there are any German plant or agronomy scientists who are part of the historical process that you've described.
Yeah, well, the U.S. definitely were interested in studying German agricultural science, and there were certainly missions to investigate those programs. I would be very surprised if there weren't Fiat technical reports summarizing some of those missions. You can find you search for Fiat reports. I think assuming you don't just get inundated with car references. Some people have posted most of these reports out there, so you can sort of skim through them and see what they were. And agricultural science definitely would have been involved. I don't remember any specific technologies that where came out of this. But then again, it's certainly the case that some of these companies especially the bigger companies who were able to really target where they wanted to investigate, may well have not wanted to advertise their successes. So there may have been bigger successes that I haven't seen. And to the extent that agricultural science is tied to chemical science, chemistry was a very heavy target. And I.G. Farben, in particular, both led the world in a lot of chemical industry areas and was also the target of intellectual reparations and physical reparations after the war.
Thanks, Doug. I wanted to ask you about the management of data, right? You talked about the microfilm, and that really struck me as quite an old technology, actually. Like, I remember studying how the French used it in 1871 when they had been invaded by the Prussians in the Franco-Prussian War to smuggle out secret messages by carrier pigeon from Paris. So I was interested in whether or not the technology had considerably moved on since that time, and what kinds of organizational infrastructure were needed to manage that data, and also sort of from a political perspective, if it's related, for example, to the foundation of the CIA in 1947 and intelligence agencies. You touched upon that a little bit.
Yeah, there's a chapter in the book about this broader question, which is a lot of this ambition to take all of the German science technology came out of a movement that was especially big in the 1910s, but sort of hung around of people who had ambition that if we, the documentarian movement is sometimes called, or bibliography movement, the idea that if you were able to index information really well, combine that with technology like microfilm, and you could have all of the world's information available at your disposal. it's sort of the same idea that we've seen today, that if you have access to the information of the internet, you have access to all the information in the world, and therefore you'll know everything there is to know, or at least have it immediately available to hand, and you won't need to be taught any of this sort of stuff. That was a really big movement within academic circles, within libraries, and got a lot of government support in France, and some degree in the US and elsewhere in the 20s, 30s, and in 40s leading into the war. So that both spurred the ambition and gave some of the sort of organizational tools to dealing with this. There were bibliographers working in special libraries in the US, like the agriculture department in the US had their own world-leading library of agricultural science with bibliographers there, and they were the recipient and distributor of a lot of the agriculture-related information that came in. The same thing is true for some other areas. So there was a lot of apparatus in that sense. In terms of the actual sort of technology of the cameras themselves, the microfilm themselves, it's been a long time since I sort of read that chronology specifically. My memory is that at least the sort of effective for the sake of long-term storage and capturing large amounts of information microfilm was more a product of the 20s and 30s than before that, though I think certainly there were predecessors going back a long way in terms of trying to sort of shrink down photography or allow sort of negatives that you could develop things out of. So that technology certainly was evolving at the time. It also is tied to banks started using microfilm technology, I think right before in the period leading up to the war. And since then, these same organizational efforts led into the US government sponsoring a lot of distribution of science and technology, even through today, in the bibliography efforts that catalog all the things that, all the dissertations that came out in chemistry this year, or all these sort of articles that came, the top articles that came out in this area of physical chemistry this year will go through these bibliography organizations sponsored by the US government that are sort of direct descendants of the Office of Technical Services and other US government organizations that were part of these efforts.
Thanks, Doug. Well, we're nearly out of time, but I do want to make sure that there's an audience member who made a real effort to clarify a question here. I do want to make sure that you have a chance to comment on that, at least briefly. The question relates to the industrial installations in Ukraine and Western Russia that the Germans would have come across in their invasion of the Soviet Union. So did Hitler want to use some of those materials? Was there a technical component to that? And did perhaps the Allies find some of these materials in their own investigations of the Germans?
Gotcha, I misunderstood. Yeah, I don't think I've seen, I did look for any sort of Nazi looting of science and technology from the places they occupied. My impression is that there was a combination, again, of Nazi racial belief that other places weren't going to be producing stuff as high caliber as them, especially in the Soviet Union, tied to, certainly the Nazis looted everything of value in terms of physical value that they could. They burned, they raped, they pillaged. So I imagine that to some degree, any sort of like rare books were probably grabbed, rare collections that might have had value in that sense. I have not seen any references to taking any sort of Soviet scientists. I really doubt they would have done that. And I don't think I've seen anything related to sort of research facilities, which probably both the Soviet Union, once they got over their initial surprise, might have shipped east, and also the Nazis might have not seen as inherently valuable due to their own sort of ideology. But if somebody's seen evidence of that, I'd love to hear it. It's fascinating.
Thanks, Doug. That's absolutely terrific. We all learn a great deal. I'm definitely going to be taking a look at your book in the near future. As I said at the beginning of the lecture, this is the last one for a while, at least until the early fall in the virtual lunchtime lecture series. But there is our virtual version of the Saturday speaker series. The next lecture is actually on Friday. It's now the virtual speaker series. And same time, 1 p.m. to 2 p.m. this week, food educator Megan Haupt will talk about food innovation since the Great Depression and World War II, and how the global pandemic could change the way we eat. Doug, thanks again. Thanks everyone for coming, and I will say goodbye and see you all soon.
Thanks very much.